Alright guys, so here we go in our first video now that we've transitioned to online. Remember the Friday before spring break we were solving quadratic equations, and we talked about how a quadratic equation always has two solutions, and it's always an equation that's written in the form ax squared plus bx plus c equals 0. So we'll have a number in front of the x squared, we'll have a number in front of the plain x, we'll have a plain constant number here, and then generally we'll have our quadratic equation set equal to 0. And so one good way to solve a quadratic equation, if possible, is with factoring. So in other words, we looked at this equation right here. See, it's in that form. The a value is 1, the b value is -1, the c value is -6. We can factor it, and if these two parts multiply together to equal 0, then one of these parts equals 0. So either x minus 3 equals 0 or x plus 2 equals 0, and then we could solve those two parts right there and get 3 and -2. So that means if we put 3 in for x in the original equation, 3 squared minus 3 minus 6, it would equal 0. If we put -2 squared minus -2 minus 6, it would equal 0. Okay, so this is either the zero product property or the factoring method that we're using to solve these equations. Okay, we did the ones on the front. Let's look at these that were on the back here. So notice this is a quadratic equation. We think about our ax squared plus bx plus c equals 0. They've got 40 in the a position. This one is missing the plain x part, but the c value is -90. We can use our factoring property or zero product property to do that. So to factor, we always pull out a GCF. In this case, it would be 10 times 4p squared minus 9 equals 0. Okay, this is a difference of squares. It would factor again. These are both perfect squares, 4p squared and 9. There's a minus in the middle. So square root of 4p squared is 2p. So I know each part starts with 2p. 3 times 3 makes 9. Square root of 9 is 3. So 3 and 3. One's a plus, one's a minus. Still equal to 0. If this whole thing is equal to 0, then that means this factored form is still equal to 0. Okay, and the zero product property says that if two things multiply to equal 0, one of them has to be 0. In this case, we have three things multiplying to equal 0. So either the 10 equals 0, or the 2p plus 3 equals 0, or the 2p minus 3 equals 0. But if these three things multiply to equal 0, one of them individually has to be 0. Pretty sure it's not 10, so I'm going to mark that one out. If 2p plus 3 is the one that equals 0, I can solve this equation and figure out what p is. So minus 3 on both sides. 2p is -3. Divide by 2. P is -3/2. Or if 2p minus 3 equals 0, add 3. So 2p is 3. Divide by 2. And p is 3/2. So the two solutions to this equation are -3/2 and +3/2. Those are the values that would make that original equation come true. That's our answer. I'm putting it in braces to represent that it is a set of numbers. It's a set. It's a group of numbers that would make that original equation come true. I'm going to plug these into my calculator to show that I have a good answer. So 40 times -3/2 squared. Notice I'm putting that -3/2 in parentheses. Say I'm putting it in for p. Minus 90. And sure enough, when I check that, it does equal 0. If I put it in with +3/2, 40 times 3/2 squared minus 90, that also equals 0. So both of these solutions, both of these values, work in the original equation. Okay? All right, let's try another one. Now, this one is a little bit different because it looks like it's already been factored. And the temptation right here is going to be oh, n plus 2 equals 0, n minus 4 equals 0, because that's kind of what happened over here once we had them in factored form. We said, oh, each of these factors could equal 0. But notice this equation was set equal to 0 initially. This equation is not set equal to 0. It's set equal to 27. Well, if we know that two numbers multiply to be 27, it could be 1 and 27, but it could also be 9 and 3. or negative 3 and negative 9. There are multiple things that multiply together to be 27. So we can only use the zero product property when our equation over here on the left is set equal to 0. This one is not. So my first step is going to be to rewrite this equation where it's set equal to 0. So I'm going to FOIL out what I've got here. So n squared minus 4n plus 2n minus 8 is equal to 27 right now. Okay. Combine my like terms. So n squared minus 2n minus 8 equals 27. And I need this quadratic equation set equal to 0. So I'm going to subtract 27 on both sides. And I'm going to have n squared minus 2n minus 35. Because negative 8 minus 27 is negative 35. Okay. Now I have my quadratic equation set equal to 0. Now I can use my factoring. And I'm pretty sure there's no GCF. So we had an n squared. Our first coefficient here is 1, so we can use guess and check. N times n would make the n squared. 5 times 7 would make 35, and combined to give me 2. So I'm going to put a 5 and a 7. Since they multiply to be negative 35, one's going to be positive, one's going to be negative, and I think it's the 7 that's negative and the 5 that's positive. Positive 5 times negative 7 is negative 35, but when I FOIL in the middle, I'd have a negative 7n and a positive 5n, and those combine to be negative 2n in the middle. Okay. All right. Now, what I've done is I factored it, so I know that n plus 5 times n minus 7 equals 0. The only way these two pieces can multiply to equal 0 is if one of them is 0. So either n plus 5 equals 0 or n minus 7 equals 0. But one of those two pieces has to be equal to 0. So now I can solve n plus 5 equals 0. I can subtract 5 on both sides. N is negative 5. Or if n minus 7 is equal to 0, I can add 7 to both sides, and n equals positive 7. So the two solutions to this equation are negative 5 and positive 7. And if you want to plug them in for a check, you can. So I'm going to retype the original, but everywhere there's an n, I'm going to put negative 5. So negative 5 plus 2 times negative 5 minus 4, and that multiplies out to be 27, which is what this was saying it should be. So I know that answer works. If I plug in a 7, 7 plus 2 times 7 minus 4 works out to be 27. That's what we were supposed to get. So I know that's a good answer. Okay, the last one in this category, again, it's a quadratic equation. It's already set equal to 0, so that's good. We're working on our factoring, or zero product property, so we're going to start out by trying to factor this. And 294 and 216 are some big numbers. I'm thinking there's probably a GCF there. I'm going to let my calculator help me with that. So I'm going to say math, number, and I'm going to arrow down to that greatest common denominator, and I'm going to say, hey calculator, tell me the greatest common denominator between 294 and 216. So remember, I hit math, I arrowed over to number, and then I arrowed down to GCD. And it says, oh, the GCD there is 6. The greatest common factor there is 6. All right. So 6 times something would give me 294t squared. So 294 divided by 6 is 49. So 6 times 49t squared would give me 294. And 216 divided by 6 is 36. So 6 times 49t squared is 294t squared. 6 times negative 36 is negative 216. So I've got the GCF. I'm looking at this. I think it will factor again. I noticed that 49t squared is a perfect square. 36 is a perfect square. So this is a difference of squares. 7t and 7t. 6 and 6. One's a plus, one's a minus. So now if these three pieces multiply to be 0, one of them has to be worth 0. So 6 could be 0. No, it's not. Or 7t plus 6 equals 0. Or 7t minus 6 equals 0. But one of those pieces has to be 0. And then I solve for each one. So subtract 6. 7t is negative 6. Divide by 7. So t is negative 6 over 7. Or the other part, add 6 to both sides. 7t is 6 and divide by 7. t is 6/7. So for this equation, our two solutions are -6/7 and +6/7. Those are the two answers to that equation. If you want to plug them in for a check, you certainly can. So 294 times -6/7 squared minus 216 equals 0, and that's what it was supposed to equal right here. And we could check again with +6/7. Okay, so this video helped us finish up our factoring method. Some people call it the zero product property method, to remind us that once it's factored, the two parts have to multiply to equal 0. Okay? On the next video, we will look at another method that we can use to solve quadratic equations, which is square roots. But that only works in some isolated cases. So tune into that video to finish your notes there.